C3g, batch or continuous. So now we're looking at different ways that chemicals are made. They can either be made in a batch process or in a continuous process. So for batch processes, we're looking at drugs and pharmaceuticals. We're looking at ideas that are about making things that are bespoke, small quantity items such as drugs, where we're not going to make vast amounts of them. So in a batch process, the equipment will be loaded with a specific recipe. It'll then be monitored. It'll be supervised by chemists who will have to check the recipe before, during and check it afterwards that it's worked correctly. And when it's all been finished, it's going to be cleaned out thoroughly, which means that it's a very expensive process. So things made in the batch process tend to be rather expensive. If drugs are used in this process, it's easier to track them because they have a batch number on them, and if ever there's found to be a testing failure, that batch can be isolated, treated or disposed of. In a continuous process, we start making a chemical that is used in bulk, and basically it's never stopped until it breaks down. It just continues making it. For example, making ammonia in the Haber process, continually adding ingredients or reactants and constantly taking out products. There's no need for cleaning because there's no recipe change, and there are no or very few staffing costs. We don't have to pay for chemists to check it all the way through. It's often very automated, so the things made in the continuous process are usually much cheaper. We've already touched on the idea of making drugs. So when a new drug is developed, we start off with an idea. Then, using computer modelling, we actually see what the drug would look like, what chemicals are involved and its structure. Then chemists will have to go away and make some, just to see how it's made and the best way to make it. Then it's going to be tested on animals, starting off with very small animals or even samples of tissue, then moving on to larger animals, and if it passes this stage, then volunteers will be tested to make sure that there are no side effects, and then it'll go on to the affected group. And when it goes to the affected group, there'll be things like double-blind trials to make sure that the patient and the doctor administering the drug have no idea whether they get the drug or a placebo to make it a fair test. Drug development is very expensive and it's a slow process. If you think if any of these stages go wrong, are there any problems, people given the drug might have really nasty side effects, so it has to be thoroughly tested, which is why it takes so long and is so expensive. A lot of the chemicals in new drug development are found in plants, particularly new exotic plants that have been found, and we have to get the chemicals out. So the first stage is the plants are crushed to break down some of the tougher biological material. Then it'll be boiled, so the chemicals inside burst through and rupture through cells. Then all the chemicals are dissolved in a range of solvents. Once we have these solvents, we use chromatography to separate them, and then we can identify individual chemicals inside there.